For my project, I have a related rates problem. In this problem, a 6-foot tall person walks away from a 10-foot lamppost at a constant rate of 3 feet per second. What is the rate that the tip of the shadow that the person creates from the lamppost moves away from the pole? And so this triangle demonstrates this scenario. The 10 feet here at the edge represents the pole, and the 6-foot red line here represents the person. And what the question is asking is, what is the rate of change of the derivative of y plus the derivative of x? And what is given so far is the derivative of this y portion here, which is 3 feet per second. In order to solve this problem, we need to set two equations that are equal to each other and then solve to isolate y and x. In this example, by dividing the triangle based on the person, we can create two triangles that are congruent and therefore set them equal to each other. On the left side of this equation, we have 6 over x represented by the long side of the triangle versus the x portion, and then the bigger triangle, which has a length of 10 here, and then the other side would be x plus y. And then solving that out, we get the equation y equals 2/3 x. Now that we have an equation that relates the triangles, we have to take the derivative of this equation to find the rate of change, because the derivative represents the rate of change of, in this case, feet per second. And so we take the derivative of y equals 2/3 x, and that equals dy over dt, which is equal to 2/3 dx dt. And then we can substitute the value of 3 feet per second for dy dt, and then from there we can isolate dx dt and find that it is equal to 4.5 feet per second. Now that we know what dx dt and dy dt are equal to, we can solve for dy dt plus dx dt. And we take those two values, 3 feet per second, which was given to us, plus the 4.5 feet per second that we found. We add those together to equal 7.5 feet per second. And this value is the rate of change that the bottom portion of the triangle changes as the person walks away from the pole. Now, to illustrate the situation with a graph, the red line is graphed as y equals 2/3 x, which is the line of the relation between y and x that we found from the triangle. And then also graphed that follow the line are x equals 4.5 and y equals 3, and these both intersect at the same point along the y equals 2/3 x graph. And this shows that these 2 points are the ones that equal y equals 2/3 x at this point, and show that the graph is accurate to the situation. And so to finish up this problem, we have concluded that the rate that the tip of the shadow moves away from the pole is 7.5 feet per second.